Welcome everyone. Welcome back to my live stream. And yeah, today we're gonna do some JavaScript/TypeScript stuff. I want to check out the JSR, the JavaScript Registry, the new thing from the creator of Node.js and Dino, I believe. And yeah, it sounds exciting. And I would like to move the GPT API Framework there so that it still works with ValTown, but it could work with some, like with Node.js or Dino or whatever other applications. So yeah, I'd like to try that and see what happens. So let me set up here quickly, as I didn't have much time yet. Alrighty, so let me share my screen. And we can look up JSR.io, I believe. There we go. JSR, the open source package registry for modern JavaScript and TypeScript. That's the thing. And it has a few nice ideas. So, yep. Let's just see if we have anything about it. Why JSR? So, it's made for TypeScript and ESM. JSR is designed for TypeScript. You publish TypeScript source. The JSR handles generating API, the API docs, the type files, and transpiling your code for cross-runtime compatibility. JSR packages are distributed as web standard ECMAScript modules. So that's the thing. You can write your library in TypeScript, and you don't have to set up any transpilation or basically any pipelines. You just upload your TypeScript code, and JSR will just straight up make sure that it runs on Node, it runs on Dino, it runs on Bun or whatever else. Cloudflare workers, and probably a million other things. So that's the fun part. And on top of that, you get the API docs, just like for packages that you have, you write in Go language or in Nim, you publish it, and from your source code, it automatically generates all the docs for it. So finally something modern for JavaScript, because as much as, NPM is awesome, that there's just so much, and it works somewhat decent. The problem with it is that, it's just old by now. So much has changed in JavaScript world that I think we need a good fresh start. So builds on NPM, JSR isn't a replacement for the NPM registry. It's a superset of NPM. JSR modules can be used with any JavaScript package manager, and in any project with a .NOTE module folder. So that's the thing. It already works with NPM, it works with Yarn, it works with PNPM, and works with Dino, it works in ValTown. Just, it just works with everything. So it doesn't mess anything up in current workflows. Works in any runtime. Node.js, Dino, Bun, Cloudflare workers, and more. Module authors can count on great editor support from strongly typed modules without the need to transpile and distribute typings manually. So it just takes away the big pain of setting up TypeScript in your project. So I want to test that. So still curious? Yes, learn more. So we've got that introduction. In addition to these shifting requirements. Okay. The incredible success of Node.js has been driven in large part by the success of NPM. With 2 million going on 3 million packages, NPM is likely the most successful package manager and registrar in history. The JavaScript community should look on this accomplishment with pride. And that's true. It's just amazing. There's nothing like it. So why build JSR when NPM exists? Because the world today is not the same as it was when NPM was originally introduced. That's true. ECMAScript modules have arrived as a standard. The web platform has now adopted ESM as the module format of choice, superseding CommonJS. Then there are more than JavaScript runtimes than just Node.js in browsers. With the emergence of Dino, Bun, Workerd, and other new JavaScript environments, a Node.js-centric package registry no longer makes sense for the entire JS ecosystem. So that's true. TypeScript has emerged as a de facto standard. TypeScript as a superset of JavaScript and testbed for the latest ECMAScript features has emerged as a default choice for non-trivial JavaScript codebases. A modern registry should be designed with TypeScript in mind. I very much like it. As far as I know, you can use TypeScript, you don't have to. So it's an optional feature. In addition to these shifting requirements, there are also opportunities to improve the developer experience, performance, reliability, and security of NPM. JSR was created to address these new requirements and take on these opportunities. Here are a few reasons why we think you should consider using JSR. So, native TypeScript support. I think that's like my main reason, because I like TypeScript, I like using it. I don't like making sure that it's, that I transpile stuff to JavaScript. That's why I like ValTown and Dino and Bun, for example. I believe Bun. I don't remember now. But, you can do stuff in TypeScript and not worry about setting it up. It just works, right? And why would you want to set it up? Why would you want to hassle with it? You can consider it as a full-fledged language, so why need for, so many settings, so many ways to just complicate your life? I understand that, this was initially because so many projects were slowly switching from JavaScript to TypeScript, but I feel like there's less and less of that, and people just, start from TypeScript most of the time nowadays. So I don't know. It would be nice to not have to deal with this whole configuration mess. JSR was designed with TypeScript support in mind. TypeScript source files are published directly to JSR. Platforms like Dino that natively support TypeScript can use these files directly. That's the thing. For other environments like Node.js that lack native TypeScript support, JSR will transpile your source code to JavaScript and distribute your modules with the .d.ts files to support TypeScript tooling for Node.js projects. No additional configuration or build steps are required on the side of module authors. And that's the best thing. I remember, I'm not like dumb with configuring JavaScript stuff, but I genuinely had trouble figuring out how to make sure that my library works for various, node environments. Oh, it worked in Bun, but suddenly on normal Node.js, there are some weird warnings and errors that something's not there. And then setting up all the stuff for example, GitHub Actions, just to be able to run tests, and you need to set up a bunch of stuff so that your TypeScript works, to make sure it compiles, transpiles, and all that stuff. I'd like to, avoid that if possible. JSR will also generate reference documentation for packages from TypeScript source code, providing rich online documentation that you can maintain alongside your code. And that's awesome, because that means that every package, literally every package that there is, will have its own documentation. So all the packages have documentation right alongside where you download them, which is awesome, because that means that you don't have to suddenly have 30 separate documentation websites for your 30 packages that you work with. So that's not a nice thing to consider. I mean, I get it, like something like Vue.js or React or something. They still will have docs that walk you through the whole library and stuff. But like the actual API of the project, that usually was a separate website anyway. So now it's gonna be right alongside your library, and package manager. So that's awesome. Next, ECMAScript modules only. The web standard for JavaScript modules is ESM. A modern package registry should rally around this standard and shift the community in this direction. For this reason, JSR was designed for ESM only. That makes me very happy, because there's always the problem that, this new thing came in and maybe people want it as a standard, like it was with ESM. People like it, but there are so many existing things, so many existing projects that just won't get updated. And if JSR becomes something, something larger than this right now, that it will start getting adopted, then hell yeah, that's gonna keep pushing people to update their libraries, or whenever they will be making a new library, they will set it up the way it's supposed to be. Although here the whole idea is that you don't have much to set up in the first place. So yeah, that's a chance for finally the ESM standard to being pushed more and more projects being just more modern. Cross runtime to support. That's also awesome. The goal of JSR is to work everywhere JavaScript works, and to provide a runtime agnostic registry for JavaScript and TypeScript code. Today, JSR works with Dino and other NPM environments that populate a Node modules folder. This means that Node.js, Bun, Cloudflare workers, and other projects that manage dependencies with a package.json can interoperate with JSR as well. We intend to expand our support of bundlers and other runtimes as time goes on, and document the APIs and techniques for doing so. So that's awesome, because that means that if I'm gonna write my, let's say, the whole idea is to get the, let me open a new tab, ValTown. I'll go to ValTown API Framework and our GPT API Framework. Right now, this is running on ValTown, this code here. It's not much, right? It's just a short little snippet of code, nothing fancy. Right now it's running on ValTown. That means it's running on Dino. And I would like to move it to JSR. And because JSR is already compatible with Dino, I can just probably, most of the moving will be copy, paste, maybe replace some of those ESM links with whatever, something else, just to make sure it still runs. But basically it'll be copy paste, and I should be able to push it to JSR, and it will automatically generate all the files so that I can still use it in Dino. I will be able to use it in Node.js or in Bun or Cloudflare Workers, wherever I will want to. I just have one code that's just TypeScript, nothing else, and I won't have to worry. If there are problems, I don't know, maybe JSR gives some errors and suggestions what went wrong. I don't know, we'll see. So next, JSR is a superset of NPM. The NPM registry has been incredibly successful thanks to the contributions of developers worldwide. We want JSR to build on this success, not fork it. JSR is a superset of NPM, much as TypeScript is a superset of JavaScript. JSR is designed to interoperate with NPM-based projects and packages. You can use JSR packages in any runtime environment that uses Node modules folder. JSR modules can import dependencies from NPM. That's awesome. That means that some of the things I'm importing here, right now I'm importing Hono framework from NPM and Zod from NPM. Maybe they're already in JSR, I don't know. But if not, just in case, I can import them from NPM and it should still work. So that makes me very happy. Okay. An outstanding developer experience. JSR has many features aimed at helping module publishers become more productive, including but not limited to easy publishing with a single command. The CLI will walk you through the rest. Awesome. Automatic API documentation generation from source code. Awesome. Zero config publishing from GitHub Actions. Awesome. That is super awesome. Okay. I'm looking forward to that. We're going to set it up. Automatic inclusion of .d.ts, TypeScript definitions files for Node.js/npm distribution. Automated guidance on TypeScript best practices that will keep your code loading as fast as possible. Interesting. So I guess that's the little messages that will show up like, hey, you could improve this, and much more. And nearly the last one. Fast, secure, and reliable. JSR is intended to be secure, fast, and flexible, and also work well in resource-constrained environments. Awesome. JSR uses a global CDN to serve packages and uses local caching and high parallelism to speed up downloads. JSR package uploads are mutable, so you can trust that packages will never change after downloading them or disappear underneath you. That's good too, because there were some problems with that. JSR package downloads are efficient, downloading only the exact files you are importing. Yeah, not like loading 20,000 files just because, I don't know, something. I guess you won't be loading all the docs if you're just importing the library, right? JSR uses OIDC-based authentication for publishing packages from CI, and uses a tokenless interactive authentication flow for publishing from local machine. Cool. JSR is still evolving. Your feedback will be critical to the success of JSR. If you have any ideas or feedback on how JSR could work better for your use case, please let us know on Discord and either the JSR or JSR feedback channels. Ready to try JSR yourself? Get started now. Let's get started. So, using JSR packages. Add a package to your project using one of the commands below. This will add the most recent version of Luca cases to your project. What is Luca cases? Collection of functions for converting strings between different cases. Oh, okay. Split pieces, camel case, snake case, cow case, turtle case, Pascal case, constant case. Oh, okay. Nice. So that's what the library looks here. Okay. Built and signed on GitHub Actions. Look at that. View transparency log. We have everything here. Oh, that's super nice that it's integrated that way. You can just inspect if everything's fine. We can have how to add package with Dino, with npm, yarn, pnpm, for example. There we go. Just add dlx, JSR, and that's it. How to import it. And if I would word Dino, bam, that's it. Awesome. It has symbols. View all 7 symbols. And I guess these are the docs. Yep. All symbols. All just those few functions. And that's it. Files. Look at that. We can inspect everything here. Oh, that's nice. We even have tests here. Cool. Okay. And there's only one version. 3 months ago. No dependencies. Few things depend on it. Okay, so we have browser here, and the score is 100%. Has a README module doc. Has examples. Has module docs in all entry points. Has docs in most symbols. No slow types are used. Has description. At least one runtime is marked as compatible. At least 2 runtimes marked as compatible, and has provenance. The package should be published from the verifiable CI/CD workflow and have a public transparency log entry. Awesome. So I can see it increasing as more little different checks. So hey, this is fun. Gosh, they're making packages, making they are making packages fun. So yeah, that's cool. Okay. Very much like it. And what does it look like if we're gonna go look at the author? No, it just shows the overall thing. Oh, and it has a link to GitHub as well. Look at that. Very, very, very simple. 100% TypeScript. No JavaScript required. Okay. So that looks fun. So on Dino, we just do that. On NPM, we do that. And after adding the packages, can import it and use it in ES modules. Excuse me. Yep, import it and just use it. In Dino, you can optionally use JSR packages without an install step using JSR specifiers and Dino's native support for JSR. Yeah, because in Dino, you don't have to specify that this depends on this and that. You just straight up import it if you want to. You can find more packages on JSR.io. Okay. Publishing JSR packages. JSR packages are published using the JSR publish/Dino publish command. You can publish packages from your local machine from CI or from CI. That's awesome. First, write your code. JSR packages are written in JavaScript or TypeScript and are published as ES modules. So we just define mod.ts. We give it some kind of documentation, and we just export a function. Again, I give it docs. And I presume that's it. Then add a config file to your package. This file contains package metadata like the name, version, and entry points. The exports field tells JSR which modules should be importable by users of your package. Okay, so we specify. We either do a JSR.json or Dino.json. Cool. Name, version, and exports. In this case, it's the same directory, mod.ts. Oh wow, this is rather simple. Finally, run npx JSR publish or Dino publish to publish your package. You will be prompted to authenticate with JSR, and then your package will be published. Okay, cool. Publish. Visit there to authorize, I guess, yeah, confirm. Authorization successful. Publishing. Published. And there we go. That's it. And the version just sits here, just like in normal JSON little package. Hey, that's fun. I guess we have a little bit more about it. So let's just go quickly through the rules and we'll start getting going. Okay, both code written originally to use package.json and code written originally for Dino can be published as JSR package. JSR supports and encourages publishing TypeScript source code rather than pairs of JavaScript plus TypeScript definition files. This allows JSR to provide more helpful auto-generated documentation and helps provide improved auto-completion and editors. So what are the JSR package rules? All packages uploaded to JSR are automatically processed and verified during publishing to ensure that all code hosted on JSR abides by a consistent set of rules. These rules are designed to enable portability across environments. Your code must follow these rules to be able to be published to JSR. So if ESM modules only, yes, that's awesome. JSR packages are published as ESM modules. This means that you can only publish modules that use the import and export keywords. You cannot publish COML.js modules. Awesome. NPM packages are supported. You can depend on NPM packages by either specifying them in the dependencies of your package.json or by referencing them in code using NPM specifiers, such as import clone deep from npm low-4. Okay, that's what we're doing right now here. Okay, we're importing npm HONO 3. That's awesome. JSR packages are supported. You can depend on JSR packages by specifying them in the dependencies for your package.json or referencing them in code using JSR specifiers. So the same thing, we just add JSR. So that's awesome. Node built-ins are supported. You can import Node.js built-ins using the Node scheme. For example, you can import the FS module using import read file from, we have Node FS. So again, we just go here and we are actually using that. We're using the buffer from the node, which I guess we could try to remove at some point. Because I'm sure there's different way to avoid using from node. Cool. Simple file names. File names must be Windows and Unix compatible. That's another good requirement, so that it works on both. This means that file names cannot contain characters like the asterisk, colon, or question mark. You may also not have multiple files with the same name, but different casing. Good. Preferably no TypeScript slow types. To speed up type checking, support documentation generation, and Node.js compatibility, JSR packages should not use certain TypeScript types in exported functions, classes, or variables. This is enforced by default, but can be opted out of. Slow types. What are slow types? What are slow types? Slow types occur when a function, class, const declaration, or let declaration is exposed from a package, and its type is not explicitly written, or the type is more complex than what can be simply inferred. Some examples of slow types. This function is problematic because the return type is not explicitly written, so it would have to be inferred from the function body. Okay, so yeah. Basically, whenever you write a function, specify what the return type should be. And that's a good practice because that makes sure that whatever the function you're going to write, you know, the compiler will check if you're still doing the correct thing. We have this, we have that, and this property is problematic because prop is foo plus bar. Oh, okay, this property is problematic because the type is not explicitly written, so it would have to be inferred from the initializer. So it needs to infer it from this, which is inferred, this, which is inferred, and suddenly we're exporting this. And, you know, a bunch of inference. Okay, slow types are internal. The slow types that are internal to a package, for example, are not exported from a file that is the exports of the package manifest, are not problematic for JSR and consumers of your package. So if you have a slow type that is not exported, you can keep it as is. So we have the export add that, you know, takes two numbers and returns a number. So we have it specified. So this is fine for export. And bam. And the internal one is like, I don't know, something, and this needs to infer what the return type will be. That's fine. Okay, because this here ensures that this is exported, this is going to get documented, therefore inference doesn't need to happen. Okay. TypeScript restrictions. This section lists out all the restrictions that the no slow types policy imposes on TypeScript. All exported functions, classes, variables, and variables must have explicit types. For example, functions should have an explicit return type, and classes should have explicit types for their properties, and constants should have explicit type annotations. Okay, so exported constants should have types as well. So basically everything export needs to have explicit types. Okay. Module augmentation and global augmentation must not be used. This means that packages cannot use declare global, declare module, or export as namespace to augment the global scope of other modules. Good. So things are not affecting each other. So that's just healthy. And I guess it will prevent some malicious code from being pushed. CommonJS features must not be used. This means that packages cannot use export equals or import foo equals required foo. Exactly, no CommonJS. All types and exported functions, classes, variables, and types must be simply inferred or explicit. If an expression is too complex to be inferred, its type should be explicitly assigned to an intermediate type. Okay. Destructuring and exports is not supported. Instead of destructuring, export each symbol individually. Okay. Types must not reference private fields or classes. Okay. So explicit types, global augmentation, CommonJS features. Yep, all that. No destructuring exports. So don't do that. Don't export like constant foo and bar. That you just do that. Just set it as constant and export them one by one. Okay, no big deal. Types must not reference private fields and all that stuff. Okay. Makes sense. Ignoring slow types, we don't care about that. Okay. Good to know. And the last thing is valid cross-file imports. All of the relative imports between modules in your package must resolve at publish time. The format of supported specifiers depend on whether a package.json is in use and is elaborated below. To publish a JSR package, you must first write the code for your package. JSR packages are written in JavaScript or TypeScript and are published as ESM modules. So we'll just set up the module, right? Relative imports. Package can consist of multiple modules. You can reference other modules in your package using relative imports. You should use the correct extensions and imports, like greet.ts to import the greet.ts rather than greet or greet.js. When a package.json is present in your package, modules may use sloppy imports with sloppy imports. With sloppy imports, you can import files without extension, or with a .js extension, even if the entire... Okay, but we won't be doing package.json, okay? Importing from npm packages, yep, we just need to either set up the dependency or just import it in that way. Importing JS, okay, Node.js bulletins, dependency manifest. You might use a dependency manifest like a package.json or an import map like dino.json file to simplify your imports. During publishing, JSR publish/dino publish will automatically rewrite the specifiers in your source code to fully qualify specifiers that do not require an import map/package.json anymore. Okay. Okay, mod.ts where we can export this one and this one if we have them imported in like dino.json or import map.json. Okay, we might go with like dino.json or something, because I would just like to set up Dino project, and this way I don't have to deal with any TypeScript stuff and just keep going, right? And I'll trust JSR to make it run on npm and everywhere else. Preventing slow types, yes, and package config file. After you have written your code, you must add a config file to your package. This file contains package metadata like the name, version, and entry points. This file should be named JSR.json. Dino users can also include the required JSR properties in the dino.json to avoid having to create another file. Okay. They will be separate for configuring JSR packages. That's awesome. Creating a scope in package. JSR is organized into scopes. A scope is a collection of packages. Scopes are similar to npm organizations. Scopes are prefixed with an @ symbol and are followed by a name. For example, @Luca is a scope. You can create a scope at JSR.io new. Scopes names must be between 2 and 32 characters long and can only contain lowercase letters, numbers, and hyphens. You can only create a scope if the name is not already taken. Scope names that are very similar to existing scope names, for example, ones that only differ by a hyphen, are prohibited. Oh, that's awesome. Very awesome. After you have created a scope, you can create a package in that scope. You can create a package at JSR.io new. Package names must be between 2 and 20 characters long. Okay. It can only contain lowercase letters, numbers, and hyphens. Okay. Not taken and not similar. Okay. Good. With this similar stuff, that's very good because, again, some bad actors, they can't just create another package that just looks the same, nearly the same or whatever. Then verifying, publishing from local machine, publishing from GitHub Actions, filtering files, okay. Ungit ignoring files when not using include. Okay, I see. So let's try the JSR IO new. Or I'll just open a new tab. Here, there we go. Okay. So scope, choose which scope your package will be published to. Scopes are namespaces of packages. Okay, I have my scope. Awesome. And then package name. In my case, it will be GPT API Framework. Okay. I get created now to publish a package. Okay. Wow. Configure. Pick a publishing method, and that's it. Wow, this is really nice. Okay. This is gonna be fun. And what if I'm gonna go to another new? Oh, no, let's just do that for now, okay? So let me try to figure out how to publish another thingy. I mean, not publish. Let's just set up the project for that. Let's install Dino. Let's search how to install Dino. I want to try out Dino. I never tried out Dino, I believe, or maybe a long time ago. Okay, we have some stuff to run on Windows. On Linux is nearly the same. Okay. Docs. Okay, so this is basically that. Additional installation options can be found here. Okay. Try the server. Oh, I guess it's that simple. Sure. PowerShell. Was installed successfully. Dino, help. There we go. Dino works. Dino version. We have Dino 143.6. Okay, that was simple to install the package. That's awesome. I like it. So we're done with that. Now I'm gonna open up, where do I have it? Let's open up WebStorm or whatever, or I should probably actually create a new repo for the package. New repository. GPT API Framework. Okay. Description. Let me see if I can just copy description that already exists somewhere. Let's write something quickly. Simplifies creation of APIs for custom GPT actions. Okay. Sure, let's add readme. Git ignore will be for Dino. There's no git ignore for Dino. Well, let's ignore then. That'll be MIT. There we go. create a repository. All right, let's clone it quickly. And let's go here. Clone a repo. And that'll be from GitHub. API. GPT API Framework. Let's clone it. Open it. Okay, we have the API cloned. Now I can go to WebStorm. And let me just open the package quickly. So let's do open. And when I open it, we can go to repos and we have the GPT API Framework. Okay. Let's make it a bit larger. So this is our stuff here. So let's figure out how we can create a Dino project. Okay, install Dino. That's it. Create a simple web. Create a TypeScript file called this and that. That's it. Really? First steps. Create run TypeScript program. It's just that, but it doesn't have like, you know, to create Dino something, Dino setup. Set up your environment using this and that. Generate, so you can get support for Dino, WebStorms, and other different, including blah, blah, blah. So the official Dino plugin from preferences. Okay, we're gonna do that. So let's see. Settings, plugins, and marketplace search for Dino. Okay, that's the official one. Install it. I will need to restart, unfortunately. I presume. Or maybe not. But that's it. Shell completions. No. Command line interface. Help and compile, run. Script arguments, watch mode, hot module replacement. Really? Dino.json configuration. Oh, there we go. Dino supports a configuration file that allows you to customize the built-in TypeScript compiler for modern linter. Configuration supports JSON and JSON-C extensions. Since 1.18, Dino will automatically detect Dino.json and JSON-C configuration file if it's in your current working directory or parent directories. The config flag can be used to specify a different configuration file. Okay. So acts as an import map for resolving bare specifiers. So we can specify imports right here or add tasks. Okay. That's simple. So let's see what our JSR recommended here. Okay, for both Dino.json and JSR, it just says, hey, just use that. So, okay. New file. Dino.json. Okay. We have it large enough for stream? I think so. Okay, so that's that. We have it saved. I'm happy with that. The version must be Semver format. The exposed field specify this and that. Okay. So mod.ts will be our exports. Okay, makes sense. MPEG publishing for publish via CLI. We'll be using Dino publish, and that's it. That's literally it. Settings. Description is shown on the package page and search results. What did we specify in here? Browser, I need to stop using it. So simplifies creation of APIs for custom GPT actions. And can we add some more? Sure, let's just for now provide some of that, and we can then go from there. Okay, we have show malform request. Description must not be longer than 250 characters. Really? Simplifies creation for custom GPT actions. So it would be nice to show like a little how many characters are left. Ask for automatic generation of Phono API compatible with GPTs. Inputs and outputs need to be specified via types from which it was. So let's do. The OpenAPI spec is generated automatically available via this save. Okay, now it worked. Browsers. I don't think that will be in browsers. We will for sure say that Dino is supposed to be supported, and I want Node.js to be supported. Browsers, I don't think so. No, not browsers, because that's for running a server. So let's save that, and then we can specify GitHub repository. Okay, so let's get our. I just specify it like this, right? Sconti. Here, save. There we go. Okay, this looks great. That was like the simplest thing ever. I really like the interface. I really like it. So, okay, so let's go to our package. We have this specified here. So we need to create our mod.ts where we'll be exporting things. So let's look at our existing code. What do we have there? We have our GPT API Framework. Let me just copy everything for now. I mean, everything from the actual thing and paste it here. Let's see what happens. So we have a bunch of stuff imported from ValTown, which is GPT API Schema Builder. I don't care about that right now. HTTP verb and buffer and uncached on missing npm package. And then we have Hono and Zod. Okay. And we have a bunch of interfaces. So yeah, let's start splitting it up. Okay. I don't think for this little framework, I don't think we will have to create an additional directories. Let's just, can I just do something like, refactor, and do we have something like extract interface? Huh. Nope, cancel. Let's just create a new file. API info.ts. Let's just do api-info.ts. And we're gonna grab this thing. Get it out of here. Just gonna paste it here. And we just export that interface. Everything's specified here, so that's good. We have our docs already specified here. Let's just add additional for the title. The title of the API. The name of the API. It gives the AI an idea of what the hell is that English? Where did it copy from? I guess from my... It gives the API an idea of the purpose. An idea about the purpose of the API. The GPT instead of AI. An idea about the purpose of the API. Okay. And then version. Oops. Let's say required by the Open API spec. Okay, we just have those things specified. So this is this also needs the docs, right? So let's do preparing for object that is used to describe the API to the GPT. Sure, let's call it that way. Okay, so that part is moved. And we just import this from api-info.ts. Okay, so that's done. Then we have a bunch of those interfaces for ins and outs, and in out. So this is like one category of those, right? But they depend on the endpoint definition base from a different thing, from the GPT schema builder. And I would like it to be all just one project. So let's go here, and we should be able to control click on this guy. There we go, GPT API schema builder. So again, let me grab everything and just create new file. What was it named? GPT API schema builder. Let's just call it open API schema. I'll just schema builder. Okay, let's just call it simply. We'll again need the HTTP verb. So let's create another file. http-verb.ts. And we're gonna copy that as well from another package. That's literally this. That's all it is. It's just a little helper that exports type HTTP verb that needs a list of available or like of supported HTTP verbs. Okay. And we just export that. No big deal here. This way we can import this from http verb.ts. There we go. That's gonna be happier now. And therefore we have this whole endpoint definition base, and we can put other stuff there. So let's request schema, response schema, all that. But what was this? Extends endpoint definition base. Okay, so let's grab those two, take them out of here, and let's do new file, endpoint definitions.ts. We'll just have those two here. The verb needs to be here. Okay. Have the endpoint. Oh, we'll need a Z. I mean the Zod in there as well. So I should be able to go to Dino, right? And imports. So will be. How do I specify those in Dino? Those npm imports. Or maybe JSR already has some. Okay. Let's just make sure that exports include exclude. Okay, whatever. JSR. Zod. What is the normal author of the Zod thing? Just overall Zod. Huh. So let's search for it. Zod TypeScript. Okay. Colon hacks Zod. Okay. That's it. Zod.dev. Yeah. Do we have like instructions for it or something? Installation from npm from Dino land X. Okay, so there is one for Dino. But There's nothing about JSR yet. What if we're gonna go to issues and search for JSR? Migrate to JSR. Thanks, I'll start looking into this. March 12th. Pull request last week. That will close this issue. Huh. To publish, also need a simple step to the GitHub release workflow, and that is still open. Okay, so soon enough we'll be able to use Zod from JSR directly, but for now let's stick to npm. So that's good. Let's just figure out how we can import packages from Node in there. Okay. Import maps. Using Dino standard library. Nothing. Using publishing modules. npm modules, how to use Apollo of Dino. Schema.ts, solve, but yeah, that's how it's being imported. But can I specify in the imports themselves? Those import maps. We specified JSR this. So I guess we could. Huh. Yeah, we can import it that way or that way. Load. Oh, there we go. Duh. Just like that. Okay. Okay, that makes sense. So in our Dino, we can add to imports something like this, but we'll replace it with our Zod, right? So let's see, npm Zod. Can we? It was with @ symbol, right? So let's see what can we specify here. We don't have any completion. So let's look up Zod. What version is the last version? 3.23. Sure, let's use 3.23. 3.0 is fine. Okay. And that will be Zod. Okay. So that should work now. This way we shouldn't need to do this. Or do we? I think we had it here in an example. If we imported it like that, standard foo from standard foo. Okay. So we still need the import, but because in our Dino we specified that it's gonna be just Zod, so that means we can just Z from Zod, okay? Because this package is already known, and therefore we shouldn't worry about, later when we update Zod, we'll just update it here to use JSX, and we'll still be referred as Zod, so rest of the code won't have to worry. Okay. And we'd also need this npm Zod to JSON schema. So we're just gonna do like this. And do Zod to JSON schema. There we go. Save. And so be odd. We also need Hono. That's another thing. But isn't Hono? Let's check if Hono is in here somewhere. Hono. There we go. Version 4.4.0. Okay. That's good. So let's do Dino add and was Hono/Hono. Okay, doesn't mean it updated our Dino thing. Yes, it updated. Cool. So we should be able to replace this thing here with this. No buffer, we're gonna get there. HTTP verb goes from HTTP verb here. And this will be from schema builder, so this and that. I see. So from endpoint definitions. Okay. While this here will be get open API spec will be from schema builder, right? Okay, so that's good. This stays here. Buffer we're gonna take care of in a second. I mean, this should be already fine. Okay, and Dino at least. I don't like all those red squigglies. What the hell? Relative import. Not perfect prefix with this or that. It's not a relative import. Let me restart the thing. I can update some plugins, and let's see if restart will help with WebStorm, because I don't know. I never use WebStorm for Dino, and I hope I won't have to switch back to the VS Code. I don't like VS Code. Okay, sure. Alrighty. Still a bunch of squigglies, but oh well. We're gonna get through it, I'm sure. So what we're doing, we had this endpoint definitions, in, out, and all this stuff. So let's move that as well to our endpoint definition. This way, we have all the Z stuff. Oh, we need to do import. How do I import Z? Okay. Z from Zod. Okay, that's what should work. Well, it's supposed to work. But who knows? Maybe you won't. Okay. And that means we can go back to our mod TS. We don't need to define the base, I guess, anymore, but we'll need to import the other stuff like N out and N out. Okay. Because these are required. A bunch of those. So we took care of the imports here. Let's just finish the imports from here. So all that is good. And we just need to import the endpoint definition. Okay. That should be fine. Not complaining. Okay. It just doesn't like the Annie. But whatever. And here, again, just complains about Zod. Yeah. I don't like it so far. What the heck? Let's see what we have available in when you do Dino help. What the hell is defined here? Run, serve, add, benchmarks, bundle, cache. Cache the dependencies. Let's do that. Dino, cache. Following required arguments were not provided. File. What? You don't see the dino.json file? Really? Check. Dino, check. Why not? It's supposed to go dino.json. That's what it's supposed to use. Where the hell am I? Yeah, there's dino.json. Really? That's disappointing. What else do we have? Cache check, compile, completion, doc, eval, init, initialize new project. Okay, info, install, uninstall, lint. So let's do dino check. And what is it? Just file, dino check, dino.json. Okay. No result. Dino. What the hell was the other one? Dino cache, dino.json. Nothing. Nothing. What the hell's going on? Well, that's the first bad first impression of Dino, that's for sure. Okay, let's switch to VS Code in the meantime. Maybe that's gonna kind of work. Let me just switch to it behind the scenes quickly. So we're gonna close this guy. We're gonna get our VS Code. And what? We've got this. Do we have Dino or something? Dino. Dino from Dino Land. This is something else. Okay, so that's the official one. Okay, that's installed. So here, that's good, right? Do I have like something that's gonna tell me what I can do here? Nope. Okay, but what about our mod.ts? This buffer is declared, but its value is never read. Uncached or missing npm package. So how do I cache it if it's not working? Can I just do like Dino run or something? Oh, now this one does. Oh, come on. VS Code, you suck. Dino help. Okay, run JavaScript TypeScript program. Okay. What the heck? Dino info. Directory location, remote modules, npm modules cache. Okay, so that has access to that, so that's good. I mean, you can't really run it, right? Is there like compile the script into self-contained executable? Nope. Okay, don't like it so far. Um, so let's create a new file. Test.js or .ts. Is the import HTTP verb. Okay. And let's do something like print out a post verb. We do HTTP verb. Sure. There we go, post, right? And this thing is only refers to a type, but is being used as a value here. Oh, yeah, I guess we need to do like that, right? I will specify that this is a HTTP verb. Okay, so that should be fine. And we'll do the verb is. And I want to run this thing. Important files are used in types. Change import to import type. Okay. Sure. Okay, that's not a problem. Dino run test.ts. Okay, that run it. Okay, that's good. That's progress. What if I'm going to grab the whole create GPT API, okay? So let's do it here. Import GPT API from there, okay? And we're gonna do something like constant API is new GPT API, and we need to give it URL, title, description, version. Sure, that looks good. And now we want to do... Okay, this I guess learned from my previous things. What the hell? It knows exactly how to use it. That is crazy. I guess, yeah, that's good. So let's do constant serve function is API.serve. Okay. And that should return a function. And we do console log the serve function is this. Okay. Let's see what this prints out when we try to run it. Okay, that loaded the stuff and I guess executed it. So if I go to mod.ts, suddenly something works. This just is never read. We don't have buffer anywhere else, so we don't need it here. Okay, that's good. HTTP verb is not used anywhere. Okay. Cool, that's better. And oh, okay. Import type context from Hono. I don't know. Import type goes first or import goes first. I don't know. And I would also go with actual libraries up there, like we have Hono and all that stuff. While all the other things are just random stuff from here. So we're gonna order it in this fashion. We have A, we have E, and we have S. So that's good. I will import types first and actual imports later. Okay, I'll do that. Don't know what's better option here. Okay, CTX is some implicitly has any type. Okay, shouldn't. And policy getter is possibly undefined. Okay, but okay, we're getting somewhere. That's good. That's good. So this actually compiled. So if this works here, let me check if I can get back to WebStorm and if it still works there, because I'd like to have, you know, a little bit nicer completions and stuff. Score, what's not? Has docs for most symbols. Okay. Not really. 1 out of 5. So what? It's still complaining. Yep. So I guess WebStorm is not good for this yet. Too bad. Back to VS Code. I guess we'll need to deal with that. Okay, so we'll get through those errors in a second. We got our endpoint definitions, which are happy. This could be just types, right? Can I... quick fix. It's control period. Sure. And this... Okay, it's just type definitions. Okay, cool. So this here, endpoint definition, endpoint, yep, it defines all those, so that's nice and clear. We just need descriptions because this should be exported. And our mod TS still has the whole GPT API thing. So this is a class, so let's cut it out of here and create a new file, GPT API.ts. We're gonna paste it here. Imports weren't copied. Okay, so we need to do it manually. Let's literally cut it out of here, paste it here, and that's all there is. Okay, and it's somewhat happy. We're gonna get that fixed as well in here. Okay, so that's that. So here we should probably export them one by one, right? Export, and we do, I guess, import GPT API from there, and we do export GPT API. Wait, how can I do the imports nicely? There was some example out of it. I just jump around different languages so much that suddenly I don't even know where to look, which one was supposed to look like what. So we've got the publishing packages, right? We had the score for Hono, so let's just go to the back to the here docs. And we had a little bit about the rules. ESM only, yep. Relative imports. Importing. Okay. Preventing the slow types, config file, creating scope and package, verifying package. Where was this whole thing about the rules? Because there are the rules here, right? But I recall there was this nice thing about the exports. That wasn't the slow types, or maybe it is. Restrictions, explicit types, global augmentation. Must be simply inferred, explicit, no destructuring exports. Okay. That's just it. Okay. Let's ask ChatGPT quickly, just to see what happens. I need to export bunch of types defined throughout various .ts files in my project. All those exports need to happen in mod.ts file. How do I export those types? ESM modules. Let's see, this is a very generic question, but let's see what the hell is gonna happen. Okay, so we've got those 3 files. Whoa, require. Sure. Seriously? Mod TS. Export this from that. But this is, it's said explicitly not to export with destructuring. Okay, so this code snippet is close to what I need. Okay. The thing is that I can't export while destructuring. How can I import and then export in separate steps? I guess I'll be just able to do it one by one, like I thought. You do import this from there, this more that from there. Yeah, and just export them. Okay. So yeah, I should be able to just do that, right? Correctional statement expected. Huh? So it's expecting me to do this? No. Really? Export constant. And how do I re-export types? Structuring and exports is not supported. Instead of the structuring, export each symbol individually. Do I need to export them as constants or something? What the hell? What would it get suggested? This is suggested code. And we just put it in here. But how could I export types then? That I'm importing from different files. So we just do import, let's say, GPT API from GPT API.ts, okay? And export. Although can't do export GPT API. Okay. Import export type. But again, what's up with this? Oh, because I'm not destructuring here, right? Oh, I'm so dumb. I'm just, yep. I'm just doing that. Okay. This is not the structure, and this is just creating a new object. So I'm just being dumb. Okay. Okay. Sure. I'll be dumb. Bum bum bum. So we have the GPT API exported, okay? Mm-hmm. That's good. This is all important vars are used in types, so we can just keep making them as types. Okay, that's all it is. Cool. And let's type. I'm just gonna put it there. Type, and this is not type. So what else do I need to export? I need to export the API info, that's for sure. Or do I? Do I really need to? If I'm exporting it, that should take care of itself, I presume. Okay. Then endpoint definitions. Yes, I believe I need to export that, but I will be exporting only those 3. Okay, so let's do import endpoint in out and in out from there, and we're just gonna do export this, and this is unhappy. It's enabled, requires using export type. Oh, okay, because this is just an interface. Okay, so cool. We'll export those first. We done with that. We're done with that. And then what else do we have? HTTP verb. We should export that one. So let's do export type HTTP verb. Okay. And we'll just import it here. Import type HTTP verb. Okay. Cool. And then we have schema builder. And I don't think we need to do anything with that because we have the get schema description and path. Whatever that is right now, we don't care. Get open API spec. That's all internal, so we don't want to do anything with that. And this should be type keyword. This is just type. Okay, cool. Yeah, that should be it for the exports. Just need to provide HTTP verb and in out and in out and GPT API. So what if I'm gonna take our test.js and we're just gonna do serve function. How do I use it? Let's get here and search for HANA. Okay. Export default app. Okay. And I guess I'll be able to just serve it. Export default serve function. Okay. And let's do Dino serve test.ts. Where's export default? Fetch in the main module. Did you mean to run Dino run? Okay, so it needs fetch or something. So, what's in our API? This. So I see. Oh, I just need to. No. Let's try that. And nope, export default fetch. So default fetch. Huh? Fetch is this? What the hell am I doing? Because it is a function. Constant fetch is this. And we just do that. It just literally searches for the text. Export default fetch. Is that it? Hey, it's listening on localhost 1000, right? So I should be able to go here. Shows not found, so that's good. That's progress. We can just add GPT/schema. And we got our schema just like that. So that works. That means our code works on Dino right here. Okay, this is exciting. That means our whole schema builder worked as well. Okay. That makes me happy. And this is never used here, at least in our test. Okay. So let's think. Let's see if I can do API dot. Let's do nothing to JSON. Okay. And what do we need here? We need a path, which will be just whatever. Okay. Then we'll have method, which will be, in our case, get, because that's what we want to do, something simple. And then we have request schema, there's nothing. Description, just a test endpoint, okay? Specify this operation ID. Oh, not method, verb. Okay. Verb will be get. Okay. Operation ID will be whatever. And then we have the response schema with the object that has a message, which will be the string. Describe it as just a message, while this also describe as response shape. Okay. Oh, and we also need the whole async ctx, and I guess that'll be it. Return message hello world. Sure. Let's ignore that part. And let's try to run it again. Let me just change the song because this is horrible. Okay, this is running. So if we refresh this page, suddenly we got that there's a new path, whatever. It's a get description, just a test endpoint, whatever. Response shape has a message, which is just a message, and all that stuff, and is required. Awesome. That also means that we can go to slash whatever, and we get our hello world. And we can pretty print it if we want. Okay, that's good. So that's progress. We actually have it working like it should. Super awesome. Super awesome. So let's just start, adding the descriptions like we should. I wonder if we can just publish it and see what happens. So in our Dino.json, let's specify a different version of it. Version 0.01, okay? Let's see if we can publish it. We can do... let's just remove our test.ts, okay? And let's do Dino publish. Errors. Okay, so it won't even let us. Invoke an object which is possibly undefined. Okay, so let's fix this. The fun begins. In app.info, we don't have any problems, so that's good. Then we have endpoint definitions, no problems either. GPT API, this is where problems begin, but GPT API depends on the schema builder, so we're gonna get back here. HTTP verb is fine. Schema builder. Ooh, we've got some bad stuff here. So our exported function doesn't have return type specified. Ooh, get schema description. Zod to schema, to JSON schema. It returns object and this. Okay, so I guess I could just try to directly infer the type of it. I recall that you can do that. Let's just ask ChatGPT how to do that exactly. Let's start a new chat. Just delete all those old stuff. Okay. And this whole thing as well. So, how can I get a return type of a function in TypeScript? Let's do const abc, and I'll do type of function get abc. Okay. Whatever. So we return type of abc. Okay. So let's return type of the JSON schema. Okay. This way we have it defined explicitly. I guess this way it won't be a slow type. Wow, and suddenly it's all good here. Huh. Really? Was it that simple? We have Anna here. Paths. Oh, okay. What are we doing with paths? A paths, endpoint path. So for each endpoint and endpoints. Endpoints are of type endpoint definition. And am I returning the paths? Yeah. So I better define what the paths are because this is confusing. This doesn't say what they are. Okay. For constant endpoint and endpoints. Endpoints are just endpoint definitions, okay. This is to allow multiple endpoints with the same path but different verbs, okay? So if paths, endpoint path is not there, we just create an empty object for it, okay? So I'll say that the path is an array of, no, it's an object. It's an, it's something, okay? Oh, no. So it's a list of objects, an array of objects, okay? And okay, so we make sure that it's there. So we do path, endpoint path. So it's an array, okay, by string. Wait, what? So no, it's an object then. Should. Okay, so path is an object. So let's just make an example. So paths is, let's say, like this, right? And then will be probably by verb. And verb to lowercase, okay. Post, right? And inside of it, we specify things like description, which will be ABC, operation ID, and then request bodies, which will be the schema. Request schema is Zod type. Oof. Okay, this is not fun. Request schema. We just have something like this. Response schema. Wait, that's request body. Okay, and then responses. Oh, because we're in, oh, I see. And we're just depending if there is request schema, we just define it like this. If not, we're defining it like something else. Okay. All right. I can live with that. It's just I don't like this whole to lowercase endpoint verb, which is HTTP verb to lowercase. Why not make everything lowercase? Instead of specifying it here. This way I could specify that it's a type of that. So let's just start specifying types, okay? We'll do interface paths. No. Export type paths, which is basically what is map of string to another map of HTTP verb to endpoint definition. Let's call it endpoint schema. Okay. But this shouldn't be map. Did I mean map? Yes. Okay, that might be it. So let's do it where we have export endpoint schema. Let's do it as an interface. Interface and schema. That's how you define interfaces? Yes. So we know that this will have description, which is a string. Operation request body, and wow, okay. Let's keep trying. Is it really that? No. So if I'll say paths will be basically of type paths. Okay. It's missing the following properties from the map string. This and that. Clear, delete for each and more. How the hell do I define an object? Guess ChatGPT to rescue for the time number 100,000. How do I define TypeScript type that defines an object that takes a string as takes only strings as key, and then takes another object as value. Their value. Key string and this. Okay, I could do that. I don't mind that. Key string, and then we just do that. And then I would do another one where we have key is HTTP verb. And that. Huh. Not really. Because of that. Now I'm trying to define an object of objects, but it doesn't work. Okay, let's see. Export type paths is this. The type definition is syntax to define object of objects. You need to use the correct types of syntax. Okay. So export type paths. Oh, I need to start with this, and then inside that I have that, and then inside that I have that. Oh, I see. Did I miss it here? Yes, I just missed it here. Okay. So we can just specify it like this, and inside that we have that. And just do this and that. Okay, key is an index signature parameter cannot be a literal type or generic type because they're using mapped object type instead. Oh. Key in HTTP verb. Oh. That's just not necessary complication. But okay, paths is now better. Seriously? So let's see. So we define our paths like this, right? So if paths endpoint path is nothing, we just create empty object, right? Endpoint path is this, but it isn't happy because this is missing properties like what, really? Okay, so I have this type. Okay, we'll give it again. What how can I make it so that I can create or set this as an empty object? And let's just do something like this, okay? I'll do like let paths, and we'll just do that, okay? So I can set bum as an empty object. Okay, empty object while to the types and so specifically you can leverage the partial to allow for partial initialization. So oh, it's partial paths, really. Really? I wonder if I need that partial in the first place. Can I just do this? Nope. And nope. Oh dear. What am I even doing? That's the one part of TypeScript I don't like, that sometimes you have to fiddle so much with this whole thing. So let me think. So our paths are an object where the key has to be a string, okay? And then inside of that, we have another string that should have optional values, but where the key is this, and for each key we have value. But why does it make it like necessary or something? What the hell? Missing the following properties from that. There's a quick fix for that. Fix using compiler. What? Oh, it actually makes me... Oh, I see. So it actually forces me to have all of them defined. Discard. Okay. So let's do it. Okay, explain it. That'll be this here, okay? It's missing properties that are expected and a different type. Okay. How can I make it so that all the verbs are optional? I don't want to need to specify them. Only the used ones should be specified. Can I find it? Optional TypeScript. Well, this is my type. And let's give it the type. How can I apply, make the verbs optional in that case? I don't think this is gonna be in any way better. String is partial. Oh, I specified it there. That would make sense to actually specify it right here. Oh, that actually makes sense. That actually makes a lot of sense. I'll save it, and now it's happy. Okay, that's we moved a few lines forward. And this isn't happy because I'm specifying it to lowercase, right? So let's not do the to lowercase for now. Okay. We're gonna fix that later. So the request body. And that's not happy because we probably don't have it specified properly. But that's okay, we're gonna get there. So can I duplicate it? First of all, save. Split right, sure. Because I want to keep... What happened here again? I thought we fixed that. We'll see in a second. So our endpoint schema needs to have the request body specified properly. So let's see. We specify description, operation, and request body. So basically, if we have the endpoint specified, we do the description endpoint. So first of all, request body should be optional. Okay. Description if it's required, and content, which will be really? Which will be key string. Okay, that's better. And get schema description. Okay. Sure, good enough. Okay, and the same thing will be for responses? No, responses need to be specified. Responses will be where key is string. Okay. The description, content, which will be again key is string. Okay. And this here is unhappy. There's not an assignable parameter of this to and that. Oh, and the schema could be optional. Or not. Haha. Let's just specify it like this. And now it's unhappy about Annie. Ugh. Come on. Schema is this or what? No. The problem's somewhere here. Return type of get schema description. Get schema description is this. Zod the JSON schema. And suddenly its object is possibly undefined. Okay, so if we have schema is what? As definitions, schema return type of this. Temporarily is better. Well, it didn't change much. So that's not it. Ugh. I am not enjoying this. What is this return type of Zod to JSON schema? Okay. So JSON schema. Target like this, JSON schema 7, JSON schema, and something else. What the heck? Ugh. Can I just do that? And just call it a day? That says that object is possibly undefined. So if schema is null, okay, return null. So this shouldn't happen anymore. Schema is possibly undefined. Not anymore. Or this. Also, no. Return type of this. What? Oh, because we're doing definitions.schema. Whatever happens should just happen here. How the hell can I ignore it or something? Yeah. So doesn't mean I just need to do that. Just in case it exists. And if it doesn't, we return no. That's it. Is it good enough? I guess it is. It's just... no. It's not accessible to Z type any blah blah blah. Schema description is not assignable to this thing. Object or null. It's not assignable parameter of type this and that. I see. The schema is type of this endpoint response schema. So what is our endpoint response schema? If we're gonna go to endpoint definitions here, is the schema or null? Okay. So basically, this isn't happy because this can be null. Therefore, here we have defined that it needs to be this thing. Okay, I see. So basically this can be null, but this doesn't accept null. So I could do or null. And this will be happy now. And you can do if schema is null, then null. Okay. There we go. That's saved. That's better. And we have those requirements that they need to be specified while not being schema or null or whatever. And the subsequent ones, right? Because this one, T-response schema needs to be this. It's not allowed to be null. So we have that taken care of. Okay, good. Some progress. We might actually finish that at some point. And we have got that. Okay, and this whole thing isn't being exported, so we're good. Okay, schema builder is done. Do we have anything else? HTTP verb. I would like to change to get to post and put delete and patch. Okay, so they will be all lowercase. This way they will work well with that whole thing. The only thing is now, in our GPT API, we just need to make sure that everything's fine. So here, what do we have here? We have GPT API. We'll define all those values here. We have the constructor, which says get and async is not needed here. Async arrow function has no await expression. Remove async keyword. Await. Okay, so basically it's upset that we don't have an await here. Okay. Can we still do that? I presume we can. Okay. So this will be our get GPT/schema, so that's good enough. And then we have the policy getter if it's not null. We specified this and await info policy getter. Cannot invoke an object which is possibly undefined. How is it possibly undefined if it says that it's not null? What the heck? Still unhappy? What the hell? What happened to the whole good inference and stuff? Let policy getter is this, and I just specify this, really? Because I guess it could change while we're... Yeah, okay, I see. Okay, let's have it that way. And we've got all this. So that was actually interesting finding that it figured out that this is, you know, like, this is within a closure, therefore this could change or something. Huh. That's kind of cool. Okay. So constructor is done. Do I need to, like, do this? Configuration of the API. Creates new GPT API instance. That's it. And then we have JSON to nothing. And we could do input definition. Definition of the endpoint. And then we have another which will be handle function that handles the request. Okay. I wonder how to add, you know, like docs for those ones here. Unless I need to specify a separate type for that, and that's how we can add that would kind of suck. Okay, async context is implicitly has an any type. How so? Wrapper is of context. Okay, there we go. Well, that request data, We'll have some to-dos here that we can improve. API key status code. Status. What's wrong here? We have type number is not assignable to parameter of type status code. And what is the status code type? Status code. Info status, success status code. Really? It is that. It's numbers. What the hell? Really? Await handler, and I will return a number as status code from Hono. And send. Already send does not exist on type of void. What? So we've got something weird going on here. Oh, maybe that's the thing that changed in Hono 4.0. Oh, okay. So let's see how we can set the whole thing with Hono. Good Hono, right? Documentation. Docs. Getting started. Sure of Dino setup. See text. Yep, all that good stuff. But in my case, I'm setting the status code, right? So API context. Status. There's no such thing as status here. It's routing in the context, yeah. On a request is yet different thing. So what's up with the context? Handle request and response. You can use context object. The request, we have the body, we have the text, render text as this, JSON, render JSON, render HTML, return not found, redirect, just response object, set get, set the value specified by the key with the set and use it later with get. Yeah, we can just get some values as middleware, okay. Can access the value of the variable with var, okay. Render, set render. You can set the layout using set render and then use render. No, thank you. Execution context. Wait until this and that. Nope. Event, environment, error, context variable map. How do you just return a status code? What the hell? Helpers? Variable helpers, adapter, cookie, CSS, factory, HTML. So status code. Wait. Let's cut that. As status code, okay. The status. What is status? Is fresh is false. This status is status. That's all it does. So context dot send return context. So how did it work with other ones? Because we had other examples. Dino. What we're doing here, it returns the C text hello. Dino. So what if we would do return context of text? Hi there, okay? What's inside text? Extend status code. What? It's a property. Really? Does it have setter getter or something? And returns text respond. Okay, so I'm confused now. Benchmarks web standards. Search for status. Status code. If you explicitly specify the status code, it will be added as a type for passing to the client. Wow, okay, you can get data, the status code. That's it. Status. Default status. Turn the HTTP response. Nope, that's not it. Return text or HTML. Return C body. Return the response body. Thank you for coming. So can I just skip the whole thing? Response is the same as below. Render text, JSON, HTML, not found, redirect. These are just those. Okay. So I guess I could return C body. Thank you for coming. And this. And headers. Okay. Response is the same as below. New response. Thank you for coming. Status code. This and that. So I guess the response needs to be there or something. Turn new response. And so that's the body, and then we have what? Response in it. So we do null, and then we do status code. Okay, I see. So that means I need to specify everything. Okay, so I can specify header, I can specify status, and then I can just return the body. Okay, so I could just do return context body, and data can be null. Comma, status code will be status code. Okay. As status code. Hopefully that works. So this should be the new solution to that. Okay. A definition is never assigned. How so? Endpoint definition. Oh, so therefore it can be constant. Okay. Okay. And this will be context again. We have JSON here. It's going to be constant. And this will be a context. And handler can return any. I guess that wouldn't be great. So if we register the handler, right? This and the handler. So get is expecting handler that returns the okay, that thing. Yeah, so it depends on ay. Get post put delete patch. Okay, so we got those. So this is JSON to JSON, right? And then we have registers a handler for verb plus path combo. Okay. Verb and path. Only depending on what we just do that. So the whatever is calling register handler. So we have the handler wrapper. Okay. So we've got the handler, and the wrapper is basically taking it and then it returns this, for example, which will be response and type response. So we can specify that register handler should be response. Okay. Or promise response, because we want to allow the async ones, I guess. Everything still works here. And these work as well because they expect a response to be sent. I wonder if that still works. Unfortunately, we deleted our test TS. So we're gonna need to retest it, I guess. So let's see what it looks like now. Test.ts. Test, please. So we'll do import GPT API from there, and we'll do constant API is GPT API, and we'll have something like the URL, title, description, version, and policy getter will just return hi there. Okay. We can just straight up do this. Doesn't even need to be async. Okay, and then we have the thing here. This will be our handler for it, right? Oh, what am I doing? This doesn't exist here. Okay. So this is our API, so we can do API dot nothing to JSON, okay? Now here we have the path. We can do the operation, verb, description, and we have our handler, okay? So what's the handler supposed to be? Promise of what? What do we specify? Infer response schema. Oh, duh. Yeah. So in our test, we also need to specify the response schema. Should be z dot object. Okay. Message string describe message. Okay. Describe response shape a message. Okay, now it looks better. So we'll just need to do return. Message will be hello world, okay? We don't need context in here. We don't need to make it async right now. It should work. What isn't happy about? Handler was not provided. Okay. Yes, it wasn't provided. So we just end this here. Will be comma. This thing here. Yeah, sure. Where will we get? Description is this. And context is this promise, so it needs to be async. Really? Deal with async being there. Jeez. And we do, what was it? Const fetch is API.serve. Okay. So export default fetch. And now I should be able to just do serve test TypeScript. Okay, we've got progress. It didn't throw any exceptions initially. So we'll call whatever. It's not found. Let's do gpt/schema. We got the schema, so that's good. Content will be whatever. Does it show like does it show anything that's being required for it? Okay. So let's go to /nothing. Just get our hello world. So that worked. Okay. Cool. I consider that some initial success, okay? That means something works, it didn't crash. So that's great. So again, how can I ignore the things? Okay, there must be some way to ignore it here. This is just how to publish. Okay, we'll just do Dino publish. That's not a problem. Porting packages. We have like some kind of, because I want to add ignoring package config file, scope, verifying package. So publish packages including performing a dry run to confirm your package meets all JSR rules, involves using JSR publish or Dino publish. The syntax for both commands is broadly identical. Okay. Cool. You can run with a dry run flag to perform all publish verification. Okay. Dino publish dry run. Let's try that. Dino publish dry run. Error. This symbol is missing an explicit type. What? Specifier, this that is missing a version constraint. Okay. So we'll take care of that. That's the schema builder? Okay, Z to JSON schema. So here we need to specify the Z to JSON schema version. So let's search for it. 323. 3.23. Okay. And that's 0. So let's run it again. And what do we have now? Missing explicit return type in the public API. GPT serve. This function is missing an explicit return type. Okay, I see. App fetch. What is it supposed to be? On environment, fetch. Okay. Returns a response or promise response. Okay. Will be this. Do I need to put it in here? Nope. Let's just do return type. This and app fetch. Huh. Type of. Oof, that's ugly. So what was the other one that was unhappy? Because there was one more. It's going to split type in the public API. App is new HANA. It's missing an explicit type. App is new HANA. Oh, so I should do it like this, I presume. So how do I rename it here? Rename symbol. Oh no, I shouldn't. This is TypeScript, right? Private. And private for the info. And private for the endpoints. Okay. And new HANA will just return no, I don't need to specify it. Jeez. This is exported nicely, this is exported nicely, and this is as well. This should be private. Okay. The register handler and serve should be public. So this is a function that takes a request and possibly environment, possibly bindings and stuff, and returns a response or promise. Ay. So can I just copy this? So it'll be return type of this. Oh, there we go. But I was probably thinking more of this. Followed by property access. This worked. So let's keep this. If it works, I'm happy. And our test still works. Okay, good. So let's clear it and do another dry run. Aborting due to uncommitted changes. Check in source code or run with allow dirty. Okay. According to okay, so that would work. But it would commit the idea files, which I don't like doing. And the test is there too, so how do I avoid those? Because I don't want to just shove everything up that can get in there. These are import maps for Dino. Let's get rid of those for now. Yeah, publishing from your local machine, that's all good. Filtering files. JSR publish will ignore files that are listed in .getignore file and in the root of your package. Additionally, you can specify to include and exclude fields in your JSR, JSON, or Dino JSON. File to exclude, ignore, or ungetignore specific files. Okay. For example, to only selectively include certain files, you can specify a glob that matches all files by using the include option. So let's just add the getignore, okay? And I'd like to do the, what was it? .idea. What else do we want to ignore? I guess we don't have anything else to ignore. Let's remove the test.ts because for now we just didn't want it there. README. Oof. Jeez, that's the part I don't like doing right now, which is writing the .getignore files. Well, okay, we've got filtering and getIgnoring. Okay, so that's all good. That's all good. So let me think. Oh, I just closed the page, right? Let's go to the GPT API. Nope. go to ValTown. So we got the schema builder, and here we have the API framework. Allows for automatic generation of this and that. Okay. Oops. Inputs and outputs need to be specified. And then there's an example. So I'll wait with an example for now, okay? We'll build it as we go. So let's just start with that, and we'll just call it GPT API Framework. Okay, let's start committing any changes. If I git ignore and yeah, everything. Move code from ValTown, okay? Let's just call it that. That should be good enough for now. Code is pushed. So let's try to actually run the Dino publish. Okay, I need to authorize. Okay, everything pushed. That was simpler than expected. Okay, GPT API Framework. There's the version 001, which is the latest. Okay. Got our little thingy. Documentation. Got our GPT API with stuff here. It actually also shows the private stuff, which is interesting. And all these are struct API key. Huh. All that is private. Okay. New GPT API. Okay, this is public, this is public, this is public. It's just kind of hard to read. Yeah, I don't really like it. Huh. I guess when I add some proper description, JSON to JSON. Register endpoint, so it has the description. It just looks kind of ugly. If it's showing the whole thing. Okay. Dependencies on Hono, Zod, and this. That's good. Dependents, nothing. Score has examples and a README or module docs. Nope. So has provenance. The package should be published from a verifiable CI/CD workflow. So we're gonna improve that. Okay. So we're gonna fix that. That's for sure. We're gonna set up an action, but that will be next time because it's kind of late. Has docs for most symbols. Yeah, not yet. So yeah, that's that. Let's see if we can improve some of the docs. I would actually like to try it if I can actually use it like immediately or something. So let's go to ValTown, okay? I'm gonna go... Wait, where's ValTown? I'll go somewhere else. I'm gonna go to tutorials, and we have the video game idea GPT, right? Wait, that's the old one. This is the new one, okay? So what I'm going to do is I'm gonna fork it, really? Can't I just clone it? Okay, fork it. And it should be unlisted. I will do test of newer of whatever JSR test. Okay, we'll call it JSR test. And instead of import GPT API from here, we're gonna do JSR this at 001 and that. Okay, let's see if that's gonna still work. Save. I know that it should be unhappy about a few things. Mostly should be unhappy about how I specify the endpoint with a post. Preview. Alright, HTTP verb post not supported. There we go. It's interesting that it doesn't show code highlighting. Post. Huh. Do I need to do HTTP verb? Preview. Okay, so it works. It's just ValTown for some reason doesn't show anything here. Huh. So what if I'm gonna do API dot Okay, so the code works. Okay, we were able to do that. We were able to go to GPT/schema, right? And we got the schema generated. So all that works. So it works in ValTown, which is awesome. The only thing is that we need to be, it'll be nice to actually get the code completion for it. So yeah, let's copy link to this JSR test. Whatever. Let's just give it like descriptive name. JSR test. No auto complete. Okay. Copy link to the val, and we can go to their GitHub, I believe. Where was it? Let's go to documentation of ValTown. Docs, and let's see what we have here. Issues. This is not it. ValTown. Product docs, blog. ValTown product. Issues. Where were supposed to be bugs published? I forgot. What the heck? Because blog, go to issues is just really don't know where to put the bugs. Let's see their GitHub. I mean, I'm gonna quickly look at the because there's bugs. Guess we can report bug on the Discord. Let's just search if JSR, but don't import types correctly. There we go. From a JSR package, types aren't imported correctly. Example val. It's a long road getting there, but we're working on this. That was from May 14th, so yeah, not a long time. Okay, I'll just can mention that. Another val example. Moved contents of a val to JSR package so that it can be used not only in ValTown, but the lack of types makes it difficult to interact with in ValTown. I'll just do that. Let's make all the val instances with capital V. Okay. Do it here. I'll thumbs up it. Cool. That's that. Okay. But seeing how easy this is makes me very happy. Very, very, very happy. Yeah. So then what the hell's going on? Yeah, let me just add, or no. Let's finish the stream. I'm just dragging along now. I ran out of stamina anyway. So, hey, I want to thank you for watching. And this was a little bit different experience. I must say that I like it so far. As in, too bad it doesn't work on WebStorm yet, but I guess we'll get there. And yes, and now ValTown will support that, so I guess I'll keep expanding the GPT API framework. Here I'm gonna add all the descriptions and stuff, and I have a few ideas of how to improve it and maybe simplify its usage a little bit. And soon enough, probably, stuff will be supported on ValTown, so it'll be nice to use it through there. So hey, thank you for watching, and see you on Wednesday.